What is that? It's a peep! Look at that guy go! Oh my goodness, so cool. How did we create that? Oh, well, I guess I'll just have to show you. So, one little trick that you'll notice here, it was initially a glitch, but I like it. He flips over, and I did figure out how to solve the flip. But I thought it was really cool, so I'm going to show you how we did that as well. So I call this script math motion because it's pretty much just math. When world is started, we create a loop, and we send that loop after 1 second, and then we send that loop back to self over and over again with interval. Interval is currently set to 0.1 seconds. We can also see that we have a variety of variables in here, including current position, x, y, and z, which are just simple number variables. And we have out by, so this is how far out from the 0, 0, 0 do we want it to be. We have speed, and then we have up by, which expands how far it's going to bounce. So normally it would just bounce 2 meters, but we're making it bounce 20 meters, so it gets up by quite a bit. And then we have hop speed, which is how fast is it going to hop. And we have y plus, which just moves it up slightly on the y. We set current position to current position plus our interval. So what current position is this is just a number, and this number goes up indefinitely. So if you remember a sine wave from trigonometry, basically all it does is it goes from 1 to -1, 1 to -1, and it does that no matter what the number is. So you start at 0 and it goes up to infinity, but it'll always stay between 0 and 1. So this number is our number that can go up to infinity, and then we're incrementing it by an interval. So we take interval and we divide it by our speed, and so this just gives us finer increments. Then we set x to be the sine of current position. So we're getting the sine value of our current position. That's going to give us that wave. Then we set y to be sine of current position times hop speed. And so what this is going to do is it's going to speed up the amount that it hops. So its movement around the edge is relatively slow, but if we didn't multiply it by hop speed, its movement up and down would be relatively slow. So this gives it that up and down motion. Then we take z and to get the cosine of current position. And so if you remember anything from trigonometry, is that sine is actually the length on a triangle and cosine is the opposing length on a triangle. And so if you have a circle, they actually form a circle. And so when you use sine and cosine together, both using current position, you get this circular motion that goes all the way around our 0, 0 point. Then we move to, with new vector of x times out by, so we're using that sine and we're multiplying it by how far do we want to go out, which is 100. And then we take y and we multiply this by up by, so that's how far up do we want to stretch the bounce. And then we move that with a plus of up y. So by using plus sign, we just move it upward. So that way we don't have it going too far below ground. Then we have z times out by, so this moves our z also out by 100, because x and z create the circle. Then we do this over 1 second, so this gives us a smooth motion, and then we're going to constantly update this every 0.1 seconds. Then we rotate with look towards to 0, 0, 0 minus the current position of self. So this is running on each of the peeps. And so we need to know where's that peep located, and we subtract its location from where we want it to look. So if you wanted this to look at a player, this would be position of player minus position of self, and that gives you the relative direction to look at. And so we need it to look relative to 0, 0, 0, so we subtract position of self. We then use with up vector 0, 0, 0. If you want it to look and not do the bounce, this needs to be 0, 1, 0. And then we have this going over 1 second as well, also running on self, and then we send the loop back to self. And that is how we create this motion, which is really cool. You might be thinking there was that really cool visual effects, that road that they were walking on, and how did we do that? Well, we use what I call peep road. It's a variation on the exact same script. We get sine of x and z, but not of y, because y, remember, that created the bounce, because y is our up and down. And so if we just do x and z and we leave y at 0, and so over in our variables tab, you'll see that y is 0, then we get the whole circular motion without the bounce. And that is how we created what I call peep road. And everything else is the same, although this should probably be 1, so that was kind of an error on my part, so just fixed an error, yay! If you were curious to see what it looks like on the peep and how we got them to start at different locations, what we'll do is we start our current position at 3.14. So the way that the position is calculated around the circle is by radians, and 1 radian is 2 pi. So that means 6.28 is a complete 360-degree circle. So 3.14 means this is going to spawn in at halfway around the circle, and then we use half of that to get a quarter of the way around the circle. And so by setting the current position to be somewhere already around the circle, we can set where it starts. And then inside of here, we can also change some of these values. If we wanted to change how far out it was, if we wanted to change how fast it was moving, we can change all of these values inside of each individual peep. I am not at this case because I like them looking the same. And then for our visual effects, it's similar. We've attached the same script and we have the current position also starting. So this one is actually at the quarter. So this is a quarter rotation around, it's 1.57. And you can see we've also adjusted the Y to be -7, so it starts lower than 0. And so this is a value you can adjust inside of each visual effects because it's not being used or manipulated inside of the script. Anyway, if you have any questions, don't hesitate to ask. Look forward to seeing you in the next one. Bye!